let's discuss units. So, why do units matter? Well, I like to tell this little story in class, and it goes like this. So, it says a Boeing Delta II uh, with expendable launch lifts. So, basically, right, they're going to Mars. And so, uh, what had happened is they launched this aircraft to Mars, and then it entered too close to the atmosphere. So here it says down here that the spacecraft, right, landed too close in the atmosphere where it burned and broke into pieces. And okay, whoa, why did that happen? And so they found that the problem was because that the software calculated the force that the thrusters needed to exert in pounds of force. And then a second piece of coding assumed that it was in the metric unit. And so apparently these were different standards between the engineers, so engineers at Lockheed Martin versus the NASA engineers. And again, the NASA engineers assumed the conversion had happened when it did not. And I mean, huge, expensive mistake. I'm sure multi-million or $billion mistake. And all right, well, what do we want to say here? Well, first of all, let's not forget to label our units in class. And so that's what we want to say, right? We have to be clear on what units we're using. So that's a good lesson there. And then the other thing that we want to kind of take away is, well, let's think about all the different areas of interest of science. And so now you can kind of quiz yourselves. So, do you know kind of the width of a human hair? And so that tends to be on the order of micrometers. So 1 times 10 to the negative 6 meters. And then the size of a sodium atom. And so what units would be used for that? And so kind of with the common units, we could use nanometer, but that's actually a little big for a sodium atom. And so chemists have this special value of angstroms. And so that is 1 times 10 to the negative 10 meters, as opposed to 1 times 10 to the negative 9 with nanometers. But we'll go over these. Is an elephant. And so, right, elephants can be on the order of tons, of course, or many thousands of kilograms. Now thinking bigger units. And then, anyone know distance to the nearest star? And so I think that's, if we want to do light years, so about 4.24, 4.35. I think it depends what star you look at. I'm looking at Proxima Centauri right now, even though I have Alpha Centauri there. So might be a slight discrepancy, but still on the order of about 4 light years, which is, let's put that in kilometers. So that would be 4.0, again, approximately, times 10 to the 13th kilometers. And so now we're seeing a bit of scientific notation as well. So we have both our units and then scientific notation to help us express large and small units. And what we want to recognize too, that we're going to be looking at the metric system. And the metric system is a little bit easier than our traditional American units. And so each type of measurement has a base unit. And then our metric system is based on multiples of 10 here. So then we can look at our base unit. And so we'll look at moles. So this is a special chemistry unit. So this is used to describe chemical quantities. So we'll kind of hold our thoughts on this one. But length, so notice our base unit is a meter. So abbreviate it with an M. And then mass, our base unit is gram. So note that that's a little different because like physics, for example, they usually use like kilograms, at least commonly. But right, just remember that your base unit is grams here with just a little g here. And then volume, liters. And then temperature, they do give here degrees Celsius. Later, we'll discuss Kelvin and why that's really a better unit for temperature. And then time, we have, of course, the base unit of seconds. And then if you were interested in information storage, of course, we have bytes, but we will not deal with that in this class. And then we'll see how these multiples of 10 are created by adding a prefix to each base unit. So we'll get into that in just a second. And so kind of, well, where are we going with this? So first of all, here's our table. Again, you don't have to panic just yet. Just take it in for a second. And then what we want to do is set up what's called our conversion factor. So this is kind of where we're going with this. And so all a conversion factor is an expression of a relationship. So it's in a fraction form, but it's just expressing, a relationship. And so we have here that there are 1,000 millimeters in 1 meter. And again, it doesn't matter which way you write it. We can write 1,000 millimeters on top or 1,000 millimeters on bottom. It's just a relationship, right? Just like we can say that 1 dozen, right, would be 12 or any other conversion factor, right? So now we could do 12 inches in 1 foot, right? Or 1 foot over 12 inches. It doesn't matter how I write this, right? It's just a relationship. It's just an expression. And then let's just kind of again see where we're going. So then we can take our conversion factor. So again, we'll use there are 12 inches in 1 foot, or 1 foot is 12 inches. And then we'll see how we can take this. And now let's kind of, again, see where we're going. We'll do one little practice, and then we'll, again, go back to our metric units, and we'll practice actually writing our conversion factors. We'll see, so we can convert. So let's do, we'll do an easy problem for warm up, just because, right, we're trying to do proof of concept. So convert 24 inches to feet. And right, you may already know the answer in your head, but let's set it up explicitly. And so we'll do now this is what's called dimensional analysis. And all this is really unit canceling or relationship canceling, right? So you're just kind of converting from one to the next. And so you begin with what you're given. So we have 24 inches. And I like putting it over 1. Some people call this like the railroad tracks, and then they, make these lines more explicitly. I just kind of make little fractions. And then, right, I'm just now going to convert. And then we pick our conversion factor such that we have the units that we desire on top. And then that means that the units that we're trying to get rid of on bottom And so then we want to pick the second one here, 12 inches, 1 foot. Now we're going to multiply across. Notice how your inches cancel. Then we can do our math, leaving us with 2 feet. So that's, again, where we're going with this. And so then in the next video, we'll go over how to kind of make our conversion factors with our metric units. We'll practice that. And then we'll start to get into the